Good afternoon, students. I hope all of you are at home and safe along with your family members. Uh, Today's video is based on system realization. In Z transform, we know that how a system is formed. System, that is the H of Z, that how do we derive an H of Z from the given difference equation. Now, in this section, we learn about how to realize or how to convert an on paper system to actually a practical implementation, making use of certain hardware blocks such as adders and delay elements. So, let us assume that this is a system. There is a present output y of n minus half y of n minus 1 minus 1 by 4 y of n minus 2 is equal to x of n minus 1 by 8 x of n minus 1. So, the first step we will do is taking its Z transform, which will give us y of z minus half z inverse y of z. Here I am assuming all the initial conditions to be 0, minus 1 by 4 z raised to minus 2 into y of z is equal to x of z minus 1 by 8 z inverse x of z. Collect all y of z terms. So, I will have 1 minus half z inverse minus 1 by 4 z raised to minus 2. Collect all x of z terms. X of z 1 minus 1 by 8 z raised to minus 1. Now, the system function or the transfer function is given by h of z is equal to y of z upon x of z, that is 1 minus 1 by 8 z inverse upon 1 minus half. Now, in some questions directly the transfer function will be given and you will be asked to realize the system using direct form 1, or it may also be given in the difference equation in this format and you will be asked to realize. So, what you have to do is get the transfer function in this form. This is the transfer function. Let the transfer function be in negative powers of z. Let it be in negative powers of z. Even if it is in positive powers, convert it into negative powers of z. Now, let us assume one more signal such that we have it like h of z is equal to w of z upon x of z into y of z upon w of z. Let this be h1 of z, let this be h2 of z. So, the entire system h of z, now we have divided into two subsystems, that is h1 of z and h2 of z. h1 of z is given by w of z upon x of z, whereas h2 of z is given by y of z upon x of z. So, similarly, this is what we are going to do here. We are going to divide this whole one system into two subsystems. So, I can divide it in this way, 1 minus 1 by 8 z inverse into 1 upon 1 minus half z inverse minus 1 by 4 z raised to minus 2. Alright, so now I have divided my one system into two subsystems, where this is my h1 of z and this is my h2 of z. So, my h1 of z, I will divide this into two parts, so that okay, h1 of z is given by w of z upon x of z, which is 1 minus 1 by 8 z inverse. So, I can also write it as w of z is equal to x of z into 1 minus 1 by 8 z inverse. This is the whole derivation I am doing. It is not for examination, you need not derive the whole thing, you just have to draw the final structure, which we will arrive at very shortly, taking inverse Z transform of this. So I'll have W of n, W of z becomes W of n, an arbitrary signal which I've assumed, and x of n minus 1 by 8. Now when will your z transform be multiplied by z inverse? When the signal is delayed by 1. So here it will be x minus 1, right? So this is my subsystem 1. Just a second. Okay, so this is my subsystem 1. So now if I want to realize this, I know that there is an output W of n. So this same we have to draw using signal flow graph kind of things. This is my W of n, right? And at the input I have x of n. So at the input I'll draw x of n. So W of n is equal to x of n minus, so I'll have a adder block here, minus 1 by 8 x of n minus 1. That means signal x of n has to be delayed by 1. So this is a delay block. Z inverse is delay block which will insert a unit delay in the signal. So this is going to insert a delay of 1 unit in x of n. So at the output of this, the signal I'll have is x of n minus 1. This signal is to be multiplied by a coefficient minus 1 by 8. So this, then I'll pass it through a multiplier block whose coefficient is minus 1 by 8. So now my signal becomes minus 1 by 8 into x of n minus 1. So at the output I have y of W of n. Clear? So similarly, let us look at a second subsystem H2 of z, which is equal to 1 upon 1 minus half z inverse minus 1 by 4 z raised to minus 2. H2 of z is given by y of z upon W of z. So let us cross multiply. So we'll have W of z is equal to y of z minus half z inverse y of z minus 1 by 4 z raised to minus 2 y of z. So again taking izt, we'll have W of n is equal to y of n minus half y of n minus 1 minus 1 by 4 y of n minus 2, since it is multiplied by z raised to minus 2. Now this again we have to realize it in the same way in which we did this, right? So at the output we have, or what we can do is take y of n on one side, rest all of them on the other side. Output we will keep it as y of n. So it will be W of n plus half y of n minus 1 plus 1 by 4 y of n minus 2. I have just shuffled the terms. Now I have given the expression in terms of y of n, right? So there is an input W of n, there is an output y of n. Let here be a summation block or an adder block. So the first term is W of n. So this will, as it is, go as the adder. The next term is y of n minus 1. Y of n minus 1, when will we get y of n minus 1? Sorry. Right, I have put the adder block here. Now the other term is y of n minus 1. How will we get y of n minus 1? By passing the signal y of n by a delay block. So at the output of the delay block I will have signal y of n minus 1 which is then multiplied by a coefficient plus half. So that I'll pass through a multiplier block with coefficient half, which has to be given to an adder. Right? There is one more term, y of n minus 2. How do we get 2 delay when it is passed through 2 delay blocks? Delay of 2 unit. इसके output पे the signal is delayed by 1 unit, hence y of n minus 1. When this signal is again passed through one more delay block, it will give a delay, one more delay. Hence, the output of this delay block will be y of n minus 2, which is passed through a multiplier with coefficient 1 by 4 and is given to a adder. Right? So now this is our subsystem 1, this is our subsystem 2. What we have to do is we have to simply club these two. इसके आउटपुट पे W of n है, इसके इनपुट पे W of n है. So these two signals, if we club, this is our direct form 1. If I draw this again, it will be something like this. Yeah, I can draw it here. X of n adder output y of n, x of n pass through a delay block, y of n passed through 2 delay blocks, इसका कोएफिशिएंट was minus 1 by 8. इसका कोएफिशिएंट was half and 1 by 4. And the system response was h of z upon 1 minus 1 by 8 z inverse 1 minus half z inverse minus 1 by 4 z raised to minus 2. So if this is a system response, this is the direct form 1 realization. You can directly draw the realization, there is no need to derive. As you can see, the numerator coefficients, the sign of the numerator coefficient remains the same and it appears on the right hand side of the realization block, and the denominator coefficients, by coefficients I mean the coefficients of z raised to 0, z raised to minus 1 and z raised to minus 2 and so on. And coefficients of the denominator, they appear on the right hand side of the realization block for direct form 1, and the coefficients are negated. Minus half becomes plus half, minus 1 by 4 becomes plus 1 by 4. So you can directly draw the block diagram. This is direct form 1 realization.